Welcome back to Tech with House. It's another day and another problem. And today we're diving into a classic LeetCode for median of two sorted arrays. This is one of those problems that shows up again and again in top tech interviews, and it is famous for separating surface level thinking from true problem solving. By the end of this video, you will not only know how to solve it, you will understand why the optimal solution works step by step. Let's get into it. So, why this problem so tricky and hard? Because you're dealing with two sorted arrays, and but you can simply merge them, and you need the answer is in log n plus n time. Most candidates immediately think of merging, but that's exactly where they lose time and fail optimization expectations. Let's let's see the problem breakdown. We're given two sorted arrays, nums1 and nums2, and we need to find the median of the combined sorted array. But here's the twist: we should not fully merge the arrays. We must return the median efficiently. Remember, if total length is odd, return middle element. If even, return average of two middle elements. So we need to return the total time complexity must be of log m plus n. Let's see some examples. So nums1 is equals to 1, 3, and nums2 is 2. So when we merge it and sort it, 1, 2, 3 is 2. The answer become the middle element is 2, so the median is 2. So for this problem also, 1, 2, 3, 4, which means their even total length, so it is two median elements, and we use the median and the average of the two, so divided by 2 is become 2.5. There is several constraints we can set, so let's implement it within log n plus n. But the first plus for solution is the most obvious solution. Merge both arrays, sort or keep sorted, and find the median. The time complexity become of m plus n, and the space complexity becomes of m plus n. Why we kept tracking the sorting of the two elements, which means the length of the first element is m, and the length of the second array. I'm sorry, not elements. The first array is m, the second array is n. So when we merge them and keep sorting, it becomes of m plus n. Why it's not enough? Because interviewers specifically expect logarithmic solution, meaning we must avoid full merging, so we need something smarter. The optimal solution is binary search. So here the key insight. We don't just actually need to merge the arrays. We just need the correct partition point. So think of it like this. And we're trying to split both arrays into two halves. So there is a left half and the right half. And and the condition is left half size becomes equals to the right half size, and every element in left is less than or equal to every element in the right. So we achieve this using binary search on a smaller array. So as we see in this, so no merging required because brute force solution is not efficient solution. As we said, the problem expects a logarithmic solution, but the brute force solution gives us the linear time is of m plus n. So we don't just use that. The inside is split both arrays into the left half and the right half, so we can guarantee by the uh, exact partition. So let's say it by this example in a simple way. So we're given two nums, so nums1 and nums2. So nums1 have 1, 3, 8, 9, 15, and nums2 have this 7, 11, 18, and 19, and 21, and 25 arrays. So the length of the sum of the two nums is 11, so we use that one. So finally answer will be the middle element. So the middle element is the sixth element, so that's the final solution. But But when we come to the real how to idea of the partition process, so we use like partitioning the arrays by using the formula, which means I tried to explain on the solution also. Um, Total becomes 11, and the left half becomes the total plus 1 divided by 2. We can get 11 plus 1 is 12, divided by 2 is 6. So the left half must be 6. So the left half becomes 6 to that matter. 2 plus 4, it becomes 6. So we can calculate this one and cut one, cut two, and just by this valuation. But what is it? When is the partition valid? The partition valid becomes the maximum left one is less than or equal to the mean of right two, and the maximum of left two less than or equal to the mean of right one. This is a valid condition. Finally, we can get perfect balanced split by for this example. One tree is the left one, the maximum left one is 3 on this place, and the mean of right two is 18, and the maximum left two is 7, and the mean of right one is 8. So we can get the valid solution. So finally, uh, we need to check two things after validating this condition. If it is odd or even, if it is odd, we can return the maximum of the two lefts, which means the left one and the left two. And if it's not odd, which means if it is even low total length, we need to check it the median of the two. So how to do the maximum of the left one and the left two plus the median of right one and the right two, and the whole divided by two, we can get the median and return that solution. So the overall ticking partition it's not merged. As I said before, it is like binary search on short array and drive automatically from the total length and check post partition and compute median. We can get the time, and this time is logarithmic solution at the minimum of the two lengths, and the space complexity becomes off one. Why we didn't use the extra space? So that's it. As always, I use Python for this problem, for this hard problem also. At first time, it's to coming with an idea. It's hard, but when you see it, it's easy. So, you're watching me. It's easy. So, firstly, always binary search the smaller array. So, search will happen on the smaller array. If we have two arrays, we need to use on a smaller array because to validate the condition. So we use for that one, I use len of nums one. Sorry, if len of nums one is greater len of nums two. After this, we need to swap it because I want always the len of nums two becomes the greater. So nums one comma nums two becomes like nums one nums two comma nums one. That's it. After this condition, we use m comma n because as a problem states, the length of the two arrays, so length of nums one comma length of nums two. Yep. After this, we initialize the left and the right pointer, the left and the right pointer to using binary search. So the left be starting with 0, the right becomes m because we use a smaller array. So and also I need to initialize the total left. The total left becomes as we stated in the visualization. Total left becomes the total length, which means m plus n plus 1 divided by 2. Yep. After this, we can use the while left less than or equal to the right binary search. And after the binary search, we initially the cut one becomes the left plus the right divided by 2, and the cut 2 also becomes the total left. Yep, the total left minus the cut 1. Yep. After this one, we need to track 4 things because we have, as we said, the two arrays must separate within a 2, so we cut them at one point. So for that, we have the left and the right. So left 1, right 1, left 2, and right 2. So left 1 becomes nums of 1 at cut 1 minus 1. Why it's 1 minus 1? Because uh array indexing is initializing from 0. So but we have a condition: if cut 1 greater than 0, 0 else. If it's not the condition, we use the floating. So float the negative infinity, because we keep tracking the minimum on this one, the left one, and the right one becomes like nums1 at cut 1, because the final number happen in the left one is at cut 1 minus 1, and for this one is at cut 1. And if the cut 1 is less than the length of the first array, which means the length of the m, which means m. If not the condition, we use a floating for this one also. Float uh, at infinity. I'm sorry, for this one, it must be float. Float, yep. I'm not writing for left 2 and right 2 also. I just copy this one and changing to nums1, cut 1 to uh, nums2, and so this must be nums2, cut 2, cut 1 must be cut 2. So the set for right 1 also, right 2, it becomes like, yep. So just copying this one and paste this to this place, and it must be like 2, 2, and 2 also. And another thing that we need to memorize, this one becomes n because we're using the length of the nums2. After this, we can check the valid partition, which means the valid partition must become if left 1, as we said, left 1 less than or equal to right 2. Yep. And the left 2 is less than or equal to the right 1 also. Yep. After this one, we can check it, the length of the two arrays, the sum of the array, if m plus n can initialize the total, and you don't need to use m plus n, but I use m plus n, and modulo 2 becomes 1. After if this happened, we return the maximum of the two left. So left 1 comma left 2, so left 2. Yep. Sorry, I think this one becomes left 1 and left 2. If it's 11, we need to get the average of the two elements. So for that matter, we return it. So the max of first, we need to have the max of the two lefts. So left 1, left 2, and plus the minimum of the right 1 and the right 1 comma the right 2. That's it. So after this one, we need to have two condition, I think. So the aleph part is the left one if the left one greater than the right 2. you'd think, yeah, they're right too. So if this condition happened, we need to move a partition to the left. So the right pointer must become the cut one minus one, and the else part becomes easy. The left part is equals to the cut one plus one. And that's it. Let's check it. Yeah, what's happened? Yeah, what I missed is dividing by two because we use a median also. So I think we got it, and let's submit. Let's check it. Yeah, let's submit it. Okay. Yeah, 100%, 100% efficient. So that's it. If you found this explanation helpful, don't forget to like, subscribe, and share with your friends. This tech with host helping you become a better problem solver. Well, these code problem at a time. See you in the next.